Welcome to section 4.6. We're going to talk about limits at infinity and horizontal asymptotes and vertical asymptotes. Now, before I talk about limits at x equals infinity or negative infinity, let me just go back and do a review of what we've already done. Here we go. We did these type of examples in section 2.2, and this type of example was the behavior of a vertical asymptote. So as you approach a number on the x-axis from the left or the right, the function either blows up or it blows down, or it might blow down on either side, or it might blow up on either side. So these are easy problems, and we may as well just do these and get them out of the way. Here we go. The limit as x approaches 2 from the left, that minus sign above the 2 means from the left. So here's 2. We're coming in from this side. Okay, so that's going to be 3. I'm taking the limit, so I'm dropping the limit sign. X is approaching 2. 2 minus 2 is 0. But are those small values positive or negative? If we're approaching 2 from the left, we're taking numbers less than 2 and subtracting 2. So those are small negative numbers. So 3 over very small negative numbers is negative infinity. Okay, now let's do the same thing except come in from the right. So now we have 3 again over 0, but now that 0 is through positive values, and that's infinity. And if you wanted to verify that, you could go to Desmos. Well, I should hope you could graph this on your own using shifting techniques. Let me just show you. 1 over x looks like this. So y equals 3 over x looks almost identical. It just stretches it a little. And then when we subtract 2 downstairs, that's a shift of 2 units to this way, to the right. I'm not very good with right and left. So the function actually looks like this. And we can see as we approach 2 from the left, we're going down, and 2 from the right, we're going up. But, you know, I would just want you to keep in mind, good old Desmos is always there, and it's great. It's a great way to verify your answers. So y equals 3 over x minus 2. And there you go. You can see the behavior right there. Desmos is also a great calculator. Sometimes when I'm doing like calculation problems, I'll be like, okay, what's ln 2 divided by 17? And there you go. Okay, so that's just a plug for Desmos. And no, I don't own any stock in Desmos, I wish I did. Now let's get to the interesting stuff. When you take limits at infinity and you get infinity over infinity or infinity minus infinity, those are a do more work. Infinity over infinity is not 1, and infinity minus infinity is not 0. So the rule of thumb for infinity over infinity is divide numerator and denominator by the highest power of x in the denominator and write all the fractions with positive exponents. And I'll force you to do that on your next test. So let's do it. Here we have infinity over infinity. So I'm going to divide top and bottom by x squared, which is the highest power in the denominator. And I'm going to carry that limit sign along until the bitter end. So I'm going to go really slow here. 2x over x squared plus 3 over x squared over 5x squared over x squared minus 7 over x squared. Now, this step, 2x over x squared is 2 over x, and then we have 3 over x squared, 5 minus 7 over x squared. Now, everything's already got a positive exponent, so I'm good to go. I can take the limit. 2 over infinity is 0. 3 over infinity is 0. 5 is 5. 7 over infinity is 0. 0 over 5 is 0. When 0 is in the numerator, the fraction is 0. Note for future reference that the degree of the denominator was bigger than the degree of the numerator. So as we go to infinity, the denominator is growing much faster, and that's why the ratio is going to 0. Okay, next one. Again, it's infinity over infinity. So I'm going to divide top and bottom by x to the 2/3. So this is the limit as x goes to infinity of 2x over x to the 2/3 over x to the 2/3 over x to the 2/3 is 1. minus 4 over x to the 2/3. That's the limit as x goes to infinity. You have to simplify this because this top fraction is infinity over infinity still, and that's no good. So when we simplify that, that's x to the 1, subtract the exponents, we get 2x to the 1/3 on top, and on the bottom we get 1 minus 4 over x to the 2/3. Okay, and I'm good to go. I can take the limit. Drop the limit sign. Top, the cube root of infinity is still infinity. Infinity over 1 minus 4 over infinity is 0. Infinity over 1 is infinity. Now that means the limit doesn't exist, but if it doesn't exist in such a way that we can describe it, like infinity or negative infinity, then we write that. And note here for future reference, the degree of the numerator was bigger than the degree of the denominator. So at the race to infinity, the numerator's winning out, and it's growing much faster than the denominator. Next one has a square root in it. So we're going to divide top and bottom by the highest power in the denominator, which is actually, this is a typo right here. It's the square root of x squared. X over x is x over the square root of x squared, since x is positive. Why do I want to write the denominator as a square root? The reason is because there's already a square root over here, and I want to combine the two square roots. And I can't do that unless I write x as the square root of x squared. So I'm going to divide top and bottom by x, but on the bottom I'm going to write x as square root of x squared. So here we go. Limit as x goes to infinity. Now the top is just 5, and the bottom I can combine everything under one big square root, and I have to divide both the 4x squared and the 1 by x squared. I'll do it slowly. 4x squared plus 1 over x squared, which is limit x goes to infinity of 5 over square root. Now write this as two fractions. 4x squared over x squared is 4, and 1 over x squared is 1 over x squared. Okay, now we're done. We can take the limit. On the top we get 5, and on the bottom we get the square root of 4 plus 1 over infinity is 0. Square root of 4 is 2, so we get 5 halves. Let's see. That's all we had to do there was find the limit. But if you were asked to find the horizontal asymptote of this function, what is the horizontal asymptote of f of x equal 5x over the square root of 4x squared plus 1? The answer would be y equals 5 halves. You can't just say 5 halves. 5 halves is a number. An asymptote is a line, so it needs a y equals. The line y equals L is a horizontal asymptote if either the limit as x goes to negative infinity of f of x is L, or the limit as you go to positive infinity is L, or both. Helpful hint, for rational functions, you don't have to go to negative infinity and infinity because the limits are going to be the same. This limit is the same as that limit. So only do the positive side, it's easier. And an example of that would be this one. This is a rational function. Now, I want you all to know what a rational function is. A rational function, clearly it's a fraction, rational, right? A rational number is a fraction, but it's a fraction, it's a special fraction. The numerator and the denominator have to be polynomials. So this is an example of a rational function. So to find the horizontal asymptote, we only need to go to positive infinity. We don't need to do this. Okay, so that's infinity over infinity. I'm going to divide top and bottom by x squared, which is the highest power in the denominator. Okay, so 2x over x squared is 2 over x. 2 over x squared is 2 over x squared. 3x squared over x squared is 3, and 1 over x squared is 1 over x squared. Okay, and now we take the limit. 0 plus 0 over 3 minus 0. 0 over 3 is 0. So we're supposed to write our answer as an equation. So the horizontal asymptote is y equals 0. Y equals 0. Now, you may have learned some rules in pre-cal, and those rules are great to remember. Here they are. There are 3 cases when you're working with rational functions. if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is y equals the leading coefficients. So for example, if f of x is 3x plus 2 over 5x minus 1, the degree of the numerator and the degree of the denominator is both 1, so the HA is y equal the leading coefficients, 3/5. Now, you're still going to have to show that. Like, I want you to do the limit, take the limit as x goes to infinity and show me that. But it's nice to know the answer ahead of time. And as you get into more advanced calculus classes, I won't ask you to show me that. You can look at that and say, oh, the limit, the horizontal asymptote is 3/5. And I'm fine with that. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. And a good example of that is this one. The degree of the numerator was 1 and the degree of the denominator was 2. If the degree of the numerator is 1 more than the degree of the denominator, you have an oblique asymptote, OA, and you can find that by long division. I don't think you have any homework problems where you have to find oblique asymptotes. And that's it for this section.